Welcome, everybody. We'll be describing our work in the visualization of vanished heritage, specifically a wayfinding system we developed for an important ancient Native American site here in Ohio, USA. My name is John Hancock. I'm Professor Emeritus of Architecture at the University of Cincinnati. For 2 decades, I've led the production of media exhibits and publications about Ohio's 2,000-year-old Hopewell-era earthworks. It's now synthesized as the Ancient Ohio Trail website. My colleagues here include Dr. Jared Burks, Director of Archaeological Geophysics at Ohio Valley Archaeology Incorporated in Columbus, Ohio. Jared is president of the Heartland Earthworks Conservancy, an earthworks preservation and education nonprofit who commissioned the Junction Earthworks app that we're describing today. Also with us are Jose and Yara Kozan. They're co-founders and managing partners of Virtual Grounds Interactive, the digital content developer that designed and created the app. Their firm provides experience design, project development, and interactive content integration, including AR, for cultural heritage projects. During this presentation, I will first introduce the ancient earthworks in Ohio and explain the unique visitor experience and visualization problems presented by these spectacular yet very unusual heritage sites. Then Jared will talk about the Junction Earthworks site and how it offered an excellent opportunity for an innovative case study. Finally, Jose and Yara will examine the reasoning behind our choices of technology and review the app in action. Our aim is to illustrate how the combination of traditional printed signage and downloadable app was able to bring the vanished site to life, support site interpretations, and increase visitors' appreciation. We also hope to provide insights on possible similar applications. In Ohio, USA, we have a distinguished heritage of American Indian earthworks. They are comparable to England's Avebury or Durrington, but they are more numerous, some are even larger, and most of them are much more geometrically precise. Built nearly 2,000 years ago by a remarkably sophisticated culture now known as Hopewell, several are poised for nomination to the UNESCO World Heritage List in the next few years. The virtual heritage work on this topic began in Ohio in the late 1990s and early 2000s, when Jose and I were colleagues at the University of Cincinnati. We created virtual models of the ruined earthworks for a series of interactive video exhibits, later the Ancient Ohio Trail website, where animations are accompanied by narrative descriptions and multi-voiced interpretations. In this early work, we developed effective visual treatments for this unusual architecture and an interactive concept of stories in places, using a spatialized, exploratory, albeit pre-rendered, interface structure. Many types of vanished heritage sites now benefit from virtual reconstructions. But these earthworks present several specific problems, and visitors struggle to grasp their spectacular scope, beauty, and precision. These ancient works are difficult to visualize from a normal human vantage point for at least 3 reasons. First, they elude modern human perception. They are so large it is difficult to sense their spatial effects and ordering conceptions. Second, most are degraded by decades of agriculture to the point that their monumental scale is invisible, at best rendered only by differential planting schemes. Third, coverings of forest and undergrowth obscure even well-preserved portions of the architecture. Some sites remain elusive for visitors because of a combination of all 3 of these problems. Over the years, our media work with these sites has developed techniques specifically directed at these unique challenges. Recreating the digital models could only go so far. We needed to rethink scale cues, color contrasts, vantage points, and ways of embedding content in order to engage our audiences effectively. The Junction Earthworks app builds on this early work, but adds new media capabilities like AR. We describe here the virtual rebirth in on-site interactive media of a 2,000-year-old geometric earthwork complex in Chillicothe, Ohio.
This case study describes a set of documentation, visualization, and interpretation tools we deployed recently for one of these Hopewell Earthworks sites, a relatively small one at only about 8 hectares. The Junction Group is a cluster of geometric earthworks just outside the town of Chillicothe, Ohio. Its relatively small size and unique combination of geometric shapes have led us to suspect that it was an early experimental or developmental work in the process of perfecting the Hopewell tradition of ceremonial earthwork building. Like many of the region's ancient American Indian monuments, the Junction Group of earthworks was subjected, beginning in the 19th century, to many decades of agriculture. Plowing gradually reduced the walls and filled the ditches, although not before the design was documented in a mid-19th century engraving, a plate from Ephraim Squire and Edwin Davis's book, Ancient Monuments of the Mississippi Valley. Over 80 of the sites featured in this important volume were from Ohio. It was the first publication of the Smithsonian Institution, and it helped launch the entire discipline of American scientific archaeology. By the end of the 20th century, the Junction Group site was merely a flat, open farm field, and only a few scholars knew otherwise. But the site's earthen circles, crescents, and other figures were revealed in unprecedented detail in 2005 and then further in 2015. Magnetometers detect subtle changes in the Earth's magnetic field, and in Ohio they are exceptionally good at detecting the soil that is filled in the ancient ditches and the foundations of the embankment walls that are still present just beneath the plow layer. They are also quite good at detecting burned soil and iron objects. The first of these startling magnetic data images from the Junction Group helped motivate the site's preservation by showing the public that this was not merely another empty farm field, but instead a sacred ground where ancient Indians had invested enormous care and labor and had gathered for solemn ceremonies. A trail now takes visitors around this site. When plans were being made for new wayside signs at the Junction Earthworks, we, the Heartland Earthworks Conservancy, stepped in with the idea to add a mobile app. Today, the trail signs mark the locations of the vanished earthwork shapes, along with interpretive mowing. The app supports the 5 physical signs with in-depth videos and interviews, 360-degree panoramas of the digitally restored earthworks, and a scale model of the complex presented in AR.
The main goal of the project was to provide visitors of the Junction Group site with a tool to help visualize the mounds and understand the scale and size of this Native American site. For our wayfinding tool, the earthworks were recreated as 3D models and integrated in a virtual environment emulating the probable original landscape. We wanted to include the results of the digital reconstruction in as many ways as possible, so we decided to feature the virtual model as an augmented reality component and on interactive 360-degree panoramas that would present the restored earthworks from the viewpoints of the 5 stops along the trail. For those unfamiliar with the technology, augmented reality, AR, is the superposition of digitally generated graphics onto real-time views of the world. AR overlays 3D virtual objects on the real-world environment. AR differs from virtual reality, VR, by including the physical surroundings in the experience. While VR allows for the user to immerse in a virtual environment, AR overlays digital components around the user's real environment. The recent fire that endangered the historic Notre Dame Cathedral in 2019 sparkled conversations about best practices to ensure the preservation of extant heritage and explore the role of emerging technology, such as AR and VR, may play when historic sites are threatened by natural causes or man-made disasters, or have vanished completely. Immersive tech can greatly help with heritage preservation for future generations. Both AR and VR offer opportunities to visit vanished real-world locations in virtual environments. The foremost appeal of AR resides in its essential inclusive nature, serves as a gateway to expand available information in a playful manner. Augmented reality offers the opportunity for co-authoring the learning experience. The narrative shifts from the third-person storytelling to a first-person investigation that may change how the story unfolds.
Adding to the AR component, the inclusion of 360-degree panoramas rendered at average eye level provides visitors of the site with the opportunity to compare views from the same angle of the recreated complex within real-life surroundings. While the experience is not immersive in nature, it provides an interactive virtual tour of the reconstruction. Our proposed mobile app takes advantage of both the universal presence of smartphones and recent advances on the handheld hardware processing capabilities. Many smartphone owners are also familiar with augmented reality apps, from social media AR filters to IKEA catalogs. Our approach can help mitigate three main problems related to this vanished heritage, allowing visitors to visualize the virtual reconstruction through their smartphone screens at their own pace, compare the builder's original concept with the current site's condition, and explore the Earthworks complex from various points of view, including at eye and aerial levels. Allied to an interactive map and information pages offering additional layers of information, the app can provide a layered yet seamless experience of deeper levels of location-specific media, suited to multiple visitors. For the Junction Group project, we developed a website to help explain the approach and technologies to members of the Heartland Earthworks Conservancy. The website presents an overview of project requirements and proposed solutions, and includes selected examples of augmented reality applied to cultural heritage visualization. For those interested in reviewing this information, the website is still available.
The Junction Earthworks Trail Tour application is free for download from the App Store and Google Play and runs on newer models of smartphones and tablets. Visitors of the site who have not previously downloaded the app are able to do so by scanning a target image featured on the orientation sign or kiosk at the site entrance. Here is an overview of the app in action. The app centers around an interactive map featuring the 5 stops or points of interest, POIs, corresponding to the physical signage location around the trail. The map has GPS capabilities and provides wayfinding functionality locating the visitor in real time as they explore the site. For each stop, the application includes an information page with 2 curated video clips that offer additional insights on the earthworks and the builders, and also on archaeological work and preservation efforts. Tapping on the numbered icon opens the information page. As visitors scroll down the page, they are offered with 360-degree panorama, the curated videos, and an augmented reality component. From the top box, visitors can open the 360-degree interactive panorama. There are 5 360 panoramas of the earthworks in their fully restored condition, one for each stop, rendered from the viewpoint of the visitor as they stand by the physical sign. As the user rotates the device through a 360-degree arc, the panorama advances simultaneously. The images are high-res renderings showing the background hills and trees with more details that can be achieved in fully interactive 3D environments. The panoramas can also be viewed in landscape mode. The short video clips are included in the app and do not require additional downloads or rely on access to cellular data or internet access to play. The thematic clips are presented at 1080p resolution HD and offer interesting information and valuable insights using resources from the Ancient Ohio Trail project. The first video focuses on the Junction site, featuring animated flyovers of the restored earthworks, and other content that complements the printed sign. The second video goes deeper into interpretations of the general cultural life of the people. Visitors can trigger the augmented reality component by tapping on the icon at the end of the page. The app prompts the user to rotate the smartphone slightly around its surroundings to activate the ground detection. Once detected, tapping on the screen positions the virtual model. The 3D model is the same developed for the panoramas and positioned on a flat base. Visitors can have an aerial view of the Junction complex and the trail. Floating points indicate the 5 stops, and tapping on the icon opens an information box with a brief description. The model was populated with animated characters representing adult men and women along the trail to provide a sense of scale to the mounds. Visitors may rotate the virtual model and match their positions on the trail to understand how the structures would be distributed on their surroundings if they were still intact. The augmented reality interface offers 3 heights for visualization, so the model can be lowered or raised at will to provide new points of view for inspection. The default height is around waist level and displays the earthwork arranged in a semi-aerial view, as though photographed from altitude. The lower height allows to understand the complex from a top perspective, and when visitors hold the phone at eye level, as though taking a photo of the landscape in front of them, an especially compelling view will appear. The earthworks, as they were, as if the phone was a window and the viewer was looking into the past. The virtual mounds can also be flooded with rainwater by turning on the water layer. The interface also includes 2 image overlays that can be turned on and off and adjusted for opacity. Users can visualize the results of the magnetic data map or the 1840s Squire and Davis engraving. A third layer with a historical area photo is being incorporated in the next update. This combination of technology and interactive interfaces provide valuable information for visitors of the site, entices further the exploration of the stops beyond the signage, and keeps the visitors oriented to the scope of the trail experience while providing an historical perspective on the occupation of the site.
This Junction Earthworks wayfinding system is the first effort of its kind applied to our region's distinguished earthworks heritage. We hope it can serve as an exploratory ground for testing the application of AR technology for experience design within similar site settings and requirements. Evaluation of this prototype will be a key step in the development of visitor experience plans for other of Ohio's ancient sites, in particular the Hopewell Ceremonial Earthworks being prepared for UNESCO World Heritage inscription. I'd like to conclude with the words from Aaron Rourke, one of our former Heartland Earthworks Conservancy colleagues. He captures the sentiments of most cultural resource managers at these places. He says, "The earthworks can't be comprehended in their current state. They're too big, they're too degraded, they're too far apart, they're too covered with woods and weeds, you name it. We've simply got to fix this. We have to make them comprehensible, most immediately for the incoming World Heritage visitors, but ultimately to increase local awareness and appreciation. Until we can pile up dirt and restore the earthworks to their former proportions, and this may never happen, and we may not even want it to happen, creating an augmented reality experience is the best alternative, because it will be a compelling experience. It can be done quickly, and it doesn't cost much. In fact, it creates perspectives unavailable even if the dirt were simply piled up again."